In this video, we discuss some examples based on the path of contact, arc of contact, contact ratio. And in these examples, we have to find out that addendum circle radius, pitch circle radius, or particular gear and pinion. So this example, now in this example, here pinion and gear arrangement is given. Pinion and gear arrangement is given, and the teeth are given for that pinion and for that gear. So for pinion, that teeth are given 25. For gear, that teeth are given 60. And this tooth profile is considered as involute tooth profile with pressure angle 20 degree. Model is given 80 mm. This model is same for pinion and the gear. Addendum equal to the 1 time of the model. This addendum value is given as a 1 time of that model. So model is the 8 mm. So addendum is equal to 1 into 8 mm is equal to 8 mm. Inside determine the length of path of contact, arc of contact, and contact ratio. So with these given values, we have to find out this asking quantity. So length of path of contact is equal to, we have this expression, we derived this expression in our earlier video. So this equation, in this equation, array represent addendum circle radius for the gear. Capital R represent pitch circle radius for that particular gear. Phi represent pressure angle for that gear arrangement. Small r value is a addendum circle radius for that pinion. Small r is a pitch circle radius for that pinion. Phi is the pressure angle. Now we have to find out these values. So this expression, in this expression, there are three terms. Phi term, capital R term, capital RA term, and for pinion, small RA term and small r term. So these five terms, we have to find out. So this array value, this capital R and small r value, we can find out by using this pitch circle radius. For pinion and gear, we can find out by using this expression m into t by 2. Here t represent for the tooths on the pinion. Now for gear, capital R is equal to pitch circle radius, capital R is equal to m into capital T by 2. Now this t is a tooth for the gear. Now this t value, m value are given. These values are given, so we can find out small r value and capital R value by substituting this m is equal to 8 mm, small t is equal to 25. Okay, this m is equal to 8 mm and capital T is equal to 16 number of teeth. So this small r and capital R we have to find out. Now this capital R and small r is nothing but r plus addendum value. For gear, this addendum circle radius capital R is equal to capital R plus addendum value. Now addendum value is given as a one model. Addendum value is given 8 and 8. Only this R value we have to add it here. This R value calculated 100. This capital R value calculated as 240. So this RA and this capital RA we can find out as a 108 and 248 millimeter. Now put all these values into this equation and we will get length of path of contact is equal to 40.13 millimeter. So in this equation, RA value, we put this RA value 4 to 48. This capital R value we calculated as 240. Phi value is at 20 degree. Small RA value is equal to, this small RA value we calculated here as 108 millimeter. This small R value we calculated as 100 millimeter. Again phi value is at 20 degree. This R and this R value we already calculated 240 and 100 millimeter. Put all these values and after simplification we will get this length of path of contact is equal to 14.13 millimeter. Length of arc of contact is nothing but length of path of contact divided by cos phi. So we will get this equation, this answer 42.7 millimeter, and contact ratio equal length of arc of contact divided by circular pitch. So length of arc of contact 42.7 divided by circular pitch nothing but pi into m. So pi into m is 8 millimeter. So it becomes as a 1.7. So in this numerical, we have to find out that radius of that addendum circle radius of adenine circle for the pinion and gear. Also we have to find pitch circle radius for the gear and pinion by using this model formula mt by 2 mt by 2, and then we shift to the length of path of contact, arc of contact and contact ratio. So this is the simple examples based on the, so here in this, by this example you can visualize that nomenclature of that particular gear, nomenclature that addendum circle radius, pitch circle radius, that already we discussed in nomenclature of that gear. And now you can visualize that addendum circle radius for pinion or gear, pitch circle radius for pinion and gear, like this. In this example, again similar example we discussed here. This example is very similar. This example is very similar to the previous one. So in this example, that number of teeth on each of the two equal spur gears. Now two machine gears now here having equal diameter and equal number of teeth, having equal pitch circle diameter and equal number of teeth, and these number of teeth are given as 45. Number of teeth given as 45, and 20 degree involute profile. 20 degree involute profile. So that phi angle is given as 20 degree with 8 mm model, and with the arc of contact is 1.8 times the circular pitch. Arc of contact value is given as 1.8 the circular pitch. Determine the height of that addendum. Determine the addendum. So here we have to find out the addendum value. Here we have to find out that addendum value, and that addendum value is nothing but a addendum circle radius minus this pitch circle radius. Addendum circle radius minus the pitch circle radius. So in the previous example, find this array value. Addendum circle radius value is equal to this pitch circle radius plus addendum. Now they are asked to find out addendum value. This addendum we can find out array minus r. This addendum value we can find out as array minus r. Now we have to find out r and r. So this r we find out in previous example as a mt by 2. Now here this capital R and small r are same. Capital R has a number of teeth on the each. 2 equal spur gears are given. These are small r and capital R are equal. So we can find out mt by 2, or by using this notation m into small t by 2. So as this number of teeth are same. So here that number of teeth are given as a 40. Number of teeth are given as a 40. So here it is written as a 45. It should be 40. That number of teeth should be 40, as they consider the here 40. So put this value of number of teeth into model. M is equal to 8 millimeter divided by 2. So it will becomes as a 160 millimeter. Now length of arc of contact is given as a 1.8 times the circular pitch. Length of arc of contact given as 1.8 to circular pitch. PC is equal to pi m. So put all the value of pi and m. You will get this length of arc of contact. Again length of path of contact. So length of arc of contact is equal to path of contact divided by cos phi. So length of path of contact is equal to length of arc of contact into cos phi. So this 14.24 into cos phi, cos 20 is equal to this much of value. Now this length of path of contact we have formula like this. In terms of the addendum circle radius of gear and addendum circle radius for the pinion. Addendum circle radius for the gear and addendum circle radius for the pinion. Now this capital R and small r are same, as two gears are equal. This small array and this capital array and small array also same. If you consider this, if you show capital array and this small array same, this R, capital R and this small r also same. If you consider this equation modified like this, now we can put values in this equation. So length of path of contact we calculated here 42.286. is equal to 2 into this value, 2 into this value. Now this array value is unknown to us. Small capital R is already calculated, is 160. Put cost 20, pi angle is 20. Put all other values, and only unknown is the in this equation is the capital R. Addendum radius for the spur gear. Addendum radius for the spur gear. So find out this. After simplification, we find out this array value is equal to 168.4 millimeter. 168.4 millimeter, and addendum of that wheel is equal to capital R minus R. Capital R is equal to 8.4 millimeter. So addendum of that wheel now becomes 8.4 millimeter. So both the examples are similar to each other. And these are based on the path of contact, length of arc of contact, and of pitch circle radius by using that module and number of teeth of that particular gear. And just by simplifying, we can find out that addendum values or length of path of contact as per asking quantity. So these are the examples based on this. So one more example here considered as a two gears. Two gears are given, and in these two gears, number of teeth are given 30 and 40. Involved teeth are given, and these are both gears are meshed with each other. Pressure angle 20 degrees is given. Model pitch is given 20 mm. The length of contact on each side of that pitch point. Now here length of contact on each side of that pitch point is half the maximum possible length. Find the height of the addendum for each gear wheel. Now this path of contact. Now this A to B is the path of contact. This is the half portion. A to P is the half portion, and P to B is the remaining portion. A to P is the half portion, P to B is the remaining portion, and this represents as a maximum path of contact. These are represented as path of approach, path of recess, and path of recess. And here in this example, it is given that length of contact on each side, this portion and this portion of the pitch point is a half the maximum possible length. So these values are the half the maximum possible length. This is given in this example. So we draw this diagram similar to our previous derivation in the previous video. So PB, now here PB is equal to OP sin phi. PB is equal to this. PB is equal to OP sin phi. And this AP is equal to this QP sin phi. AP is equal to QP sin phi. This OP, this OB, this OP is a small r value. This QP is a capital R value. This QP is pitch circle radius for this gear, pitch circle radius for the pinion. So these are put here, and required path of approach is equal to, now that required path of approach is equal to r sin phi by divided by 2. Required path of maximum path of approach we have small r sin phi. So required path of approach is equal to r sin phi by 2. Again path of recess, maximum path of recess is equal to capital R sin phi. So required path of recess is equal to capital R sin phi by 2. So with this given condition, we can write for the path of approach. For path of approach, we can also write as a, like this path of approach, we can also write as a capital R square minus capital R square cos square phi raised to 1/2 minus R sin phi. Path of recess, we can write as a small r square minus r square cos square phi bracket raised to 1/2 minus small r sin phi. So put in this equation, by using this first equation and second equation, so in the second equation we put values of that particular array value and particular small array value. particular small array value. So these values, now path of approach is equal to r sin phi by 2, and path of recess is equal to capital R sin phi by 2. Path of recess is equal to capital R sin phi by 2. So put these values here. This path of approach. Now this left hand side change this as a small r sin phi by 2. This left hand side change this as a capital R sin phi by 2. And after simplification of these two equations, we will get whatever that asking quantity. In this equation, this condition is given. This condition is given as a path of approach and path of recess are the half of that maximum path of recess and maximum path of approaches. By using this condition, we simply put these values. R sin phi by 2, capital R sin phi by 2 here, and simplify this. Now simplify this equation. Here we have to find out that height of addendum for each gear. Find out that addendum, capital R and small array we have to find out. Now in this equation, find out this R value. Phi value is given as 20 degree. The small r value you can find out as a m into small t by 2. T value is given, m value is given. So you can find out small r value. Capital R value is equal to m into capital T by 2. So this m value is same. Model is same for this gear and pinion arrangement. So Taylor model is given. Teeth on that gear is given as a 40 divided by 2. Just capital R becomes equal to 40 mm. Put those values here. So in this equation, phi value is given as 20. Small r and capital R value we calculate by using mt by 2 formula. Now in this equation only unknown is a capital R. In this equation only unknown is a small r. And by simplifying this we can find out capital R value and small r value. And once we know this capital R value and small r value, we can find out addendum height of that particular gear. Addendum value for that particular gear is equal to addendum radius minus this P circle radius. R minus R is equal to this 8 mm addendum height for that gear. Similarly, for addendum height for the pinion is equal to small r minus R value. Small r value calculated is 139.5 minus small r value calculated in this here as a 120. So this addendum for the pinion you can calculate as a 19.5 mm. So these examples are based on the addendum. Find out that addendum of that gear and pinion by considering this path of contact. Path of contact having a combination of path of approach and path of recess. So these examples are based on these formulas related to the path of contact, arc of contact, and this contact ratio and the contact ratio.